Yeah, welcome back to the other part of the video. We've created the load cases, and now what we need to do is we need to create our load envelopes. The purpose of creating the load envelope is because of the way the load will be acting. For example, we might have two different cases. One, we will have a case when the underground tank is completely filled with water. Hence, there will be a load of the water acting from the inside on the underground tank, and then all the time the underground tank is surrounded by soil, so there will be another force from the outside caused by the soil. So that is one case. Another case is we can have the underground tank to be completely empty. There will be no water in the underground tank, hence there will be no load applied on the underground tank from the inside by water, but there will be a load acting from outside by the soil. Okay, so these are the two cases we are going to consider, and we are going to create load envelope for them. We are going to analyze them one by one. Then when you want to design, you will design for the one which is more critical. So let's create the load envelope. So go to load envelope and then you click on add. The first load envelope I'm going to create, this is when the underground tank is completely filled and then there is soil outside. So that means you'll be having force from the inside by the water, and be having force from the outside by the soil. Okay, so you can forward everything, then you click on add. Okay, then we have another load envelope, that is load 2. So in this case we will have the underground tank completely empty, so that means there is no water in the underground tank, hence there will be no load applied by the water. The only load we have is the load by the surrounding soil. Remember, an underground tank is completely placed in the soil. Okay, so the self weight of the tank will be acting all the time, definitely. Then we can't have any load due to water, so we are not going to add this. So just select the remaining like this. You can hold your shift and then use the arrow button, then you forward them like this. Okay, so you use this single forward. So we've only excluded all these 5 load, which is the live load due to water on each plate. Okay, so this is what we are going to use for the other load envelope. So we will still pick strength, all right, and then you can add that, then you can close for now. So now let's begin by defining the loads. So go to self weight and then you can add load under the self weight. So make sure you have the self weight, and then you can factor the self weight. Let's factor the self weight by 1.2. okay, then make sure it is added in the global Y, and then you click on add, then you can close that. We go to the next one. The next one, that is the live load due to water on plate 1. So let's go back to the diagram. So this first phase can be plate 1, this one can be 2, this can be 3, this can be 4, while the bottom can be 5. All right, so let's have that, and then now we are going to define the load. We know that the unit weight of water is 9.81 kilonewton per meter cube, and then the load that will be applied on this face, that is plate 1, that will be the unit weight of water multiplied by the half of the width along the plates, which will be 4,000. Half of each thousand is 4,000, so 4,000 mm multiplied by the unit weight of water, that is the load that will be felt at this point. Also the same load that will be felt at this point. Okay, and the load that will be felt at plate 3 and plate 4, that would be 9.81 kilonewton per meter cube multiplied by 2.5 meter, which is half of 5 meter. And then we'll be having a UDL on plate 5, that is just going to be 9.81 multiplied by the height, which is 3,000 meter. So these are the load that is going to be applied on the plate by the water. Then we are going to have from outside, that is going to be the load that will be applied by the soil. You can see when you look at the longitudinal section, you can see we have this is the top surface, which tells you that all of these points you have soil. Okay, all of these points you have soil, so the soil is surrounding the plate. Okay, so even at the cross section you have the same thing, soil. Okay, So to define this, we are going to take 1 meter width, 1 meter width of the soil, 1 meter width. All right, so the unit weight of soil is 18 kilonewton per meter cube. Then we are going to multiply it by the 1 meter width that is being applied on the underground tank from outside. So that will just be 18 kilonewton per meter cube multiplied by 1 meter, and that will be 18 kilonewton per meter squared. All right, so at every angle we will be having 18 kilonewton per meter squared as the load applied. So let's go back to Staad Pro. And then before I start applying the load by the on the plate, I would first of all like to check the orientation of this plate. So you go to label, symbol and labels, and then you can go to plate orientation. Just click on OK. You can check this. This is plate 2. You can see the positive local Z is moving away from the plate. Okay, so the opposite will be for the other side. So we can say this is negative while the other is positive. What about this side? Okay, here you can see the positive local Z is moving towards the plate. So that means for the other side, that will be negative. And then here you can see that the positive Z is going into the plate. So that is looking good. So let me close this. So all of the orientation have been observed. Then you can take them away. Then click on OK. So let me start by applying the load. Now live load on plate 1. Don't forget this first phase is the plate 1, and that is a positive orientation. The local Z is positive. Okay, so now we are going to apply the load due to the water. Okay, you can see this is live load due to water on plate 1. And definitely you should know that the live load due to water should be coming from inside and not from outside. So what I'm going to do right now is let me select this particular plate 1. To select this, you can have this in the side view, and then just select this plate. Okay, so that is plate 1, and then you can go to view to select that plate alone. So you have select plate alone. So go to live load due to water and click on add. Then you can go to plate load, go to hydrostatic load and select the plate. So I'm going to select this plate and then click on done. Then at the bottom where we have W1, that is where we have the maximum load, and the load that will be applied on that surface, that will be 9.81 multiplied by 4 meter, which is half of that width. That will be 39.24. So 39.24 is the load. Let me minimize this. So we have 39.24, and then at W2, which is at the top, we have 0. Then we have to interpolate this along the global Y. Then this should be in local Z. Then you click on add. Then you can close that. Alright, so that is done for plate 1. Then we can show all plates, and then I have to select the other plate, which will be this. Then you can view selected only. You can view selected only, and then now I will have to apply the load. So you go to live load on plate 2, and then you click on add. Then you go to plate load, you go to hydrostatic load. Let's select the plates, and then we are going to select the plate like this. Then click on done. So that is going to be the same load, but here that will be minus 39.24. okay, there is 0, interpolating Y, and then click on add. Then you can close that. So as simple as that. We can go to plate 3. So first of all, you need to put everything in front view, in all view. Then click on this. To select plate 3, I'll have to select this. Alright, yeah. Then you can view selected only, live load on plate 3. And then what will be the live load on plate 3? the live load on plate 3, that will be 9.81 multiplied by 2.5, okay, and that will be 24.5. okay, let me just say 24.5. Then we can go to add load, then you go to plate load, you go to hydrostatic load, then you select the plates. So select this one, click on done, and then at the top I'm going to have a positive 25.5. let this be 0, vary along y, and then make sure this is in local z. Then click on add once, not twice, okay, because when you click on it twice, it's going to add that same load twice. So you can go to the next one, which is live load on plate 4, but before that we need to select plate 4. So go to front view, and this should be plate 4. Okay, so we have that. So this is plate 4. Then I can view that alone. Then you can come to the load here, live load on plate 4, click on add. So this should be negative in the in the local z. So go to hydrostatic, select the plate. Now then click on done, and then here that should be minus 25.5. I think that's 525, but I can just leave it in 25.5. then y, and then click on add. You can close. Then now we are going to apply load on the bottom plate. So that's going to be a UDL. So you can go to live load on plate 5, click on add, and then you go to plate load. And what's going to be the value? The value is going to be 9.81 multiplied by the height of the tank, which is 3 meter, and that will be 29.43 kilonewton per meter squared. So we will have that. So you have 29.4, and then make sure this is in local z, and then you click on add, then you close. So now we just need to assign this. So how are we going to assign? You can just select the bottom, just select the bottom plates, yeah, and then you assign this load. Assign to selected plates, assign. You can see how it is being assigned. So that is very great. We have that. So now we are done with the loads applied due to water. We can now go to the loads applied due to soil. Let's see that in the next video.